Alright, so we'll continue with topic five for light and optics. So we'll be looking at the eye and image formation now, and you know what? It's amazing, like that there are a lot of technologies now that are based on living organisms, and one example would be the camera, right? So um, your eyes will be like a camera, only better, right? We can actually see better. We can adjust it faster. We can process information. The only difference is it's going to be harder to store images, but because like how do you retain that information? But somehow, like if we will think about it, like digital cameras are based on the human eye and how we capture light and get that image. So for today, we'll be looking at the structures of the eye, and unfortunately for you guys, we will not be able to do big eye dissection because obviously of the pandemic. Last year we did that. It was a lot of fun, and then it's not as bloody or disgusting as you think it is. It's mostly fluid anyway, and you will not see any traces of blood there. So while you're working at it, and it's fascinating to look at the different parts of the eyes, and then and understanding and then seeing how they function, right? So for today, we'll be looking at this. Pupil will be the when you look at your eye and you have that black circle there in the middle, so that will be your pupil. You have the lens here. Okay. Yes, you have an actual lens inside your eyes. You have the iris. The iris is the one that has different colors, right? So you can have a blue eye, green eyes, brown eyes, gray eyes, like those things. Ciliary muscles. So you see the muscles here will be attached to the lens. So somehow the ciliary muscles is the one controlling the shape of the lens. So that's why when you can see, you're squinting your eye. Okay, so that's the ciliary muscle. Um, working. The pupil controls how big the iris controls how big the pupil is, and then retina. So the retina will be it's black in color because black is very good when it comes to absorbing light, so and information, and that's why retina is black. Now you will notice here. So Mr. Cruz, what about this part here? There's no retina here, so and that's the reason why you have. I don't know if you've heard about this. It's you have this certain part of you that they call blind spot. So like I don't know, I forgot about it. Like I was told that you can actually just move your fingers, just focus on one thing, then move your fingers, and eventually your fingers will disappear. Okay, and then that will be your blind spot. I can't find it now, but there is a certain experiment or activity that you can do in order to determine your blind spot. Optic nerve obviously will be the nerve that transfers information from your eyes going to your brain, blood vessels, and sclera. So you have your cornea here. So this will protect the eye, and then so sclera will sorry, the sclera will protect the eye, and then the cornea somehow bends the light. Okay, so we'll look at the protecting the eye. So sclera is protective outer covering of the eye. The cornea protects the eye also, but it also bends the light coming into your eye, and then that will make it easier for the lens to bend and focus it. How light gets in? Light enters eye through the pupil. Okay, so this part here, and then iris, a hole created by the iris, a circular band of muscle. So color of the eyes, color of the iris. So if you have blue eyes, then the color of your iris will be blue. If you have green, then it's green. Iris controls the size of the pupil and the amount of light that enters the eye. So the iris here can make the pupil bigger or smaller depending on the need. So if it's really sunny outside, then obviously you don't need a lot of light. So this part here will become smaller. Okay. And again, I told you if it's dark, if it's black, it will absorb light. So what do you think will happen when you go outside and it's really sunny? Will this become bigger or smaller? Exactly. So that will become smaller when it's nighttime, it's evening. We have If you have less light, then this part will become really bigger. Okay, and that's why I don't know if you've noticed it, but there are some movies wherein they will show a cat um, who's just walking in the dark, and then all of a sudden the cat will look at the camera, and then the eyes, like the whole eyes will be black because they need more light, right, in order for them to see better. Now, next one, dilate. It becomes wider. So see here, it lets in more light. So usually in dark areas, dark places, then you will have bigger or wider pupil. It constricts or becomes smaller if you have way too much light. Well, you can use your sorry, where is it? Okay, you can use your cell phone camera. It has a flashlight, right? You can use just just a quick experiment. I'm not suggesting that you do that for a very long time. Just to see it, become smaller. Um, when light gets in, okay, so when light gets in, focusing the light. So a convex lens must be in the right position to produce a sharp image. Ciliary muscles changes the shape of the lens. So you will see here it can be thin, it can be thicker depending on how far or how close the object is. And that's the reason why some people, if the muscles are not that efficient, or if the lens have if they have problem with their um, the lens, then they will use, like me, I will use glasses to help out the lens in my eyes in order for me to see better. So image formed is upside down, and the brain corrects it. So whatever you'll be seeing, it should be upside down, but the brain is a powerful computer that will correct the image that you're seeing. Okay, in order to see light, light must strike the retina. Okay, special layer here filled with photoreceptors. So the receptors will be the one capturing the information and then sent to. Okay, so the receptor will be rods, highly sensitive function in dim light, and then the cones detect the color. Um, so again, rods for dim light, cones for color, CC. Okay, CC, cones color. Photoreceptors send messages to the optic nerve, connects eye to the brain. Brain translates messages and converts them into an image. Okay, and since the optic nerves are very close to the brain, and that's the reason why when you see something happens, you react immediately. Okay, let's say for example, if this is a very like a very hot object. Okay, just an example. If it is a very hot object, and also I was just playing with it without looking at it, then it will take a while before the information will be transferred to my brain. But if I'm looking at it and seeing it's red hot, then information will travel really fast, and I'll be able to remove my hand from, or just throw that away, right? If it's really hot. Okay, image storage. So brain is responsible for storing, and retrieving information about the image you've seen. Um, and correcting vision problems. So if you're farsighted, you can see like things from afar. And by the way, that's a dominant trait. More people are farsighted compared to nearsighted. But the trend now, because of the screen, because of the cell phone, because of the tablet, because we're looking at the computer all the time, like more and more people are becoming now nearsighted than farsighted. But well, I guess it's very helpful if you're farsighted because uh, if you're living, let's say 6,000 years ago or 5,000 years ago, and none of the areas here or communities here are developed, and then you have bear, wolves, and those dangerous animals, then obviously being farsighted would be very helpful, right? Cannot see close objects clearly. I cannot make the lens fat enough, so image falls behind in the retina. Okay, so you see here the focus here is beyond the retina. So what you need to do is to have a pair of glasses that will correct this. So somehow, like the focus will just hit the retina. Nearsighted can see near things, cannot see far away objects clearly, and I cannot make the lens thin enough. So image falls in front. Okay. So now you need the glasses that will extend this so that the focal point here will reach the retina. So eyeglasses alter the angle of the light before it reaches the eye. So image fall directly to the retina. So you see here, okay, if you're farsighted, the focus is beyond the retina. Now using glasses, it will shorten this part here so that the focus will hit the retina. Nearsighted concave lens. It's B. Okay, so it's pretty short. Okay, and that's the shape of the lens that you need. Okay. So laser surgery, a lot of people are opting for this now. Um, Laser is used to reshape the cornea of the eye. Newly shaped cornea bends light, so the natural lens focus light on the retina. Okay. So eyes versus the camera. Let light in. That'll be the pupil aperture. So I don't know if you're photography enthusiast, then you will know what those things are. Like the aperture controls the amount of light. That's why when you're taking pictures, there are some pictures that are overexposed or underexposed. Now it's according to my friends who are into taking pictures. They said that it's okay to be underexposed because you can tweak that or edit that. Right? But if it's overexposed, there's no way you can, well, somehow it's going to be very very difficult to edit the picture. Regulate the amount of light in. You have the iris, the diaphragm for the camera, eyelids when you close your eyes, shutter for the camera. So here's the thing: the the longer your eyes are open, the more light will come in. For shutter, the longer it is open, the more light will come in. So that's why for those photographers who are taking pictures, if they're taking pictures of the star, the shutter will be open for, my friend will open it for 30 seconds if it's really dark, or maybe even a minute if it's really dark. So to allow the light to come in, right? When it's sunny outside, what do? You somehow you like you your eyes are half closed or something, so that you will lessen the amount of light going into your eyes. Focuses the light. So you have lens. Okay, and then image formation. Retina photoreceptors now film for the camera. Now we're using SD cards. Changes of shape the lens, ciliary muscles, moves forward or backward. So you have your when you're focusing, you have your camera, you're moving it forward or backward in order to focus it. Well, the amazing thing about cameras, they have autofocus functions already. So structures of the eye, and that's it. So that's topic 5. Um, we are almost done with light and optics. We will play Kahoot on Friday, and then we will have a unit test on Monday. God bless you. Enjoy your day.